In our lesson, we are covering standard form quadratics today. So if you look at the beginning, we want to sketch the graph given the following information. We have vertex at 1, 2, y-intercept at 0, 4. So what we want to do is make sure you're labeling those. So there's our vertex, and here's our y-intercept, which are already graphed. So you have those two, and then our dotted line, we always want to include our axis of symmetry right down the middle. And then we can find our third point by going across the axis of symmetry. So the y-intercept is at 0, 4. The other point is across that axis of symmetry, the same amount on the other side. So we always want to match our points. And in these graphs, I always want to see axis of symmetry and the third point. So if you look at number 2, we have our vertex at -1, -7, and we have a point at -5, 1. So just because it's not an intercept, that is okay. We can still find what we need to find. We have our axis of symmetry goes through the vertex, and then our third point is the same distance away from the axis of symmetry as our other point. So we can just draw our graph straight through it, connect all the points, and you're good to go. Alright, now standard form. I've written all this stuff out because I can't write very well with this stylus. So standard form is, we've gone over it before, y equals ax squared plus bx plus c. And these are a and b are the coefficients, c is a constant. So the a, it tells you this is the coefficient that goes with x squared. It tells you the direction, up or down. If a is positive, the parabola opens up and it has a minimum. If a is negative, it opens down and has a maximum. So just like when we had absolute value graphs, same exact thing. Our c value, this is our constant. C is our constant. It tells us the y-intercept because when x equals 0, all we have left is 0c. So 0c will be our y-intercept. And then with standard form, to find your vertex, you actually have a little formula where x equals -b over 2a. So in class I gave an example, y equals -2x squared plus 4x minus 3. So to find our x, we do x equals -4, so opposite of b, over 2 times a, 2 times -2. So -4 over -4 is equal to 1. Once I get x equal to 1, I plug that back into the original equation. So -2 times 1 squared plus 4 times 1 minus 3, that adds up to -1 for y. So my vertex would be at 1, -1. So to find my axis of symmetry, just like before, it is the x value of the vertex. In this case, x equals 1. Our maximum and min are found in the vertex as well. Excuse me. So in this case, because it opens down, we're going to have a maximum at y equals -1. Range, so you can either use y is greater than or equal to, y is less than or equal to, or you can use the form over here. Alright, so let's flip over our paper. So let me get the second page. We're going to edit it so we can write on it. These are the examples, and I've written these ones out too just because it makes it easier on me. We want to identify the different attributes of f of x, graph it, and then write each function in vertex form. So the easiest thing to do, and you should do this even if I don't have a, b, and c listed there, is write out what a, b, and c values are. 1, -6, and 9. Then because a is positive, we know it opens up, and our y-intercept is always 0, and the c value, 9. When we're finding our vertex, this is the part where you have to work at it. X is -b over 2a. So the opposite of -6 goes on top, 2 times 1 goes on the bottom, 6 over 2 is 3. To find our y value, we plug that 3 back into the original equation, back up here. And so we have 3 squared minus 6 times 3 plus 9. 9 minus 18 plus 9 is 0. So our vertex is 3, 0. So from that vertex, we can find our axis of symmetry. That's x equals 3. We know we have a minimum because it opens up. And that minimum value is y equals 0 from the vertex. Domain is always all reals. And the range is y greater than or equal to 0. And you can see I graphed it from our points. We have our vertex right here. We have our y-intercept, 0, 9. We have our axis of symmetry right through the middle. So then, simple enough, find that third point, connect the dots. And then finally, vertex form. Y equals, and the A value matches up with what we have up there. So A is 1. And if you looked, we shifted from our vertex 3 to the right. So that's x minus 3, the quantity squared. Our K value is 0, so we don't have to add or subtract anything on the outside. So we get y equals x minus 3, that quantity squared. When we try our second example, A, B, and C for x squared plus 4x plus 6, 1, 4, and 6. It opens up. Our y-intercept is 0, 6. It matches up with the C value. We do our x equals negative b over 2a. X equals negative 4 over 2 times 1, which is negative 2. We plug that in. When you're plugging these in, if you're using a calculator, make sure when you're squaring negative 2, you put it in parentheses, otherwise it's going to give you the wrong answer. So negative 2 squared, which is 4, plus 4 times negative 2, which is negative 8, plus 6. That gives you 2. And so our vertex is at negative 2, 2. That gives you your axis of symmetry. X equals negative 2. It tells you it's a minimum because it's opening up, and that y is equal to 2 for your minimum value. Range, like domain, is all reals. Range is y is greater than or equal to 2. You can see we plotted out. Here's our vertex. Here is 0, 6 is our y-intercept. Our axis of symmetry, right down the pipe. And then we found our third point across the axis of symmetry from our y-intercept, and then we can graph it. Vertex form. So our vertex is negative 2, 2. We know our a value is still 1. So we shifted left 2. That means it's going to be x plus 2. And we moved up 2. So plus 2 on the outside. So y equals the quantity x plus 2 squared plus 2. And that is our standard form on quadratics.